Our lecture for today is the correlation between light intensity and distance. The nature of the light, it's much more difficult to understand than that of sound. Newton in the 17th century was convinced that light was comprised of tiny massless particles, whereas Huygens, working at the same time, argued that it must be a wave of some sort. Maxwell derived the mathematical theories of electromagnetic wave and demonstrated that light exhibited the properties expected of electromagnetic radiation. In the early 20th century, light was discovered to have both particle properties and electromagnetic wave properties. The wavelength of electromagnetic radiation, with the range from about 10 to the power minus 14 meter to about 10 to the power 8 meter. We use electromagnetic radiation over this whole spectrum in various applications of medical physics. Visible light occupies only a narrow band from about 400 to 700 nanometers. As shown is this photo. Light as a ray. Light comes to an observer's eyes either directly or indirectly from some source. The characteristic of light, the reflection, the refraction, the interference, the diffraction. Reflection light waves reflect when they strike the surface that separate between two medium. The law of reflection says very simply that when light is reflected, the angle of incidence equals the angle of reflection, as shown in this photo. Refraction light waves usually changes directions when it goes from one medium to another because of changes their velocity in the different medium. This is most easily observed for objects partially submerged in water, as shown in this photo. Interference light waves interact and interfere with each other in just the same way as do sound waves. The relative phase of the waves determines whether the interference is constructive, increasing the intensity, or destructive, reducing the intensity. Diffraction. All light waves undergo diffraction as they pass through a small opening. Speed of the light. The speed at which light travels in a vacuum is approximately, c is equal to 3 multiplied by 10 to the power 8 meter per second. Its speed in a transparent medium is always less than this, and is given by v is equal to c per n, where n is the index of refraction of the substance. The value of the index of refraction depends on both the composition of the substance and the color of the light. Intensity of the light. Intensity of the light is defined in terms of an energy flux, or power, per unit area, and has dimensions of watt per square meter. I is equal to P per A, where P is the power in watt, A is the area in meter. The relation between light intensity and distance can be given by I is directly proportional to 1 per square d. The medical applications of light. In medicine, the light in medicine is beneficial in diagnostic purposes and therapeutic purposes. Diagnostic use of light. There are a number of medical instruments use the visible light in the diagnosis, which are 1. Ophthalmoscope, used for examining the eyes. 2. Otoscope, used for examining the ears, nose, and throat. 3. Transillumination, is the transmission of the light through the tissues of the body. Transillumination is used clinically in the detection of hydrocephalus waterhead in infants, and also used to detect pneumothorax collapsed lungs in infants. 4. Endoscopes, used for examining the internal body cavities. Special purposes endoscopes are often given names indicating their purposes, which are cystoscope, is used to examine the bladder. Proctoscope, is used to examine the rectum. Bronchoscope, is used to examine the air passage into lungs. B. Therapeutic use of light. Many premature infants have jaundice, a condition in which an excessive bilirubin is excreted by the liver into the blood. The most premature infants recover from jaundice if their bodies are exposed to the visible light phototherapy. In dentistry, 1. Fluorescence is used in medicine, is in the detection of porphyria, a condition in which the teeth fluoresce red when irradiated with UV light, to in dental chair. 3. Subgingival calculus detection system. The detector features is a light that reflects off the calculus and is then sensed by an optical fiber and converted into an electrical signal to be analyzed. As shown in this photo. 4. In light cure, curing the composite resin. As shown in this photo.